In section 3.7, we will talk about inverse functions. First, let's talk about one-to-one functions. A function is one-to-one if any two inputs in the domain correspond to two different outputs in the range. So we talked about this in a previous section, where if a function is one-to-one, then the graph will pass both the horizontal and vertical line tests. For example, this function is one-to-one because the graph passes the vertical line test, which means any vertical line hits the graph only once. That makes it a function, but because it passes the horizontal line test, it makes it a one-to-one function. Whereas the second graph, the horizontal line hits the graph in two different places, meaning that this y value has two different x values, or the same output has two different inputs. Therefore, this is not a one-to-one function. Let's talk about inverse functions. If f of x is a one-to-one function, and this is a key requirement, f of x must be a one-to-one function with ordered pairs of the form ab, then the inverse function, denoted by f to the -1, it's not an exponent, but that's the notation for an inverse, is a set of ordered pairs in the form b comma a. So you can take any ordered pair ab, and its inverse will be b comma a. The order of the x and y, they switch. For example, let's find the inverse of the following function. Well, this should technically be a relation. So the 2, 6, we're going to interchange the x and y. That becomes 6, 2. For 5, 4, we are going to interchange the x and y. This becomes 4, 5. For 0, 12, we are going to interchange the x and y, becomes 12, 0. And for 4, 1, we are going to interchange the x and y. That becomes 1, 4. So this is now the inverse of the previous relation. Here's another example. If f of 5 equals to 8, now remember that the parentheses always contains your input or the x value, and the result is the output or the y value. So this is the point 5, 8. We want to find out what is f inverse of 8. Now, the inverse of 5, 8 is the point 8, 5, which means in the inverse, if the input is 8, then the output will be 5. So when you have the inverse of f, the 5 and 8, they interchange. So if the 8 became the input, then the 5 will become the output. If the 8 became the input, the 5 becomes the output. Another one, if f of 6 equals to 0, then what is f inverse of 0? So the input is 6, the output is 0. Its inverse is going to be 0, 6. So for the inverse, if the input is 0, then the output is going to be 6. Let's do the same thing with the table. First, let's find f of 7, which means we want to find the value of the function f when x equals to 7. So if our input is 7, then our corresponding output is going to be 6. Now let's solve f of x equals to 8. So once again, we have our input x, and our output is 8. So we want to figure out what is the value of x when the output is equal to 8. So let's find an output of 8, which is here, and the corresponding input is 1. So x equals to 1 because when the output is 8, the corresponding x value or the input is going to be 1. Next, let's find f inverse of 6. Okay, so f inverse of 6, this means that we're looking at the point 7, 6. So this is the point 7, 6, and its inverse is 6, 7. So for the inverse, when the input is equal to 6, the output is going to be 7. In other words, this point 7, 6, if we switched it around, if we made the 6 into the input, and the corresponding output is going to be 7. If f inverse x equals to 1, then what is x equal to? So here, we want to find out for the inverse, which input has an output of 1? Okay, so if I take the inverse of the point 1 comma 8, that'll be the point 8 comma 1. So when the output is equal to 1, then the corresponding input is equal to 8. So notice that if you take the point 1 comma 8 and you interchange the x and y, that becomes 8, 1. So when the output is equal to 1, the corresponding input is going to equal to 8. Let's quickly graph f of x equals x squared using a table of values. So in the center, we are going to put x equals to 0, and x squared is going to be 0 squared, which is also going to be 0. So our vertex is going to be 0, 0. If x is 1, we have 1 squared, which is 1. If x is 2, we have 2 squared, which is 4. So the corresponding point is 2, 4. If x is 3, we have 3 squared, which is 9. So the corresponding point is 3, 9. If x is negative 1, we have negative 1 squared, which is 1. So the corresponding point is negative 1, 1. If x is negative 2, we have negative 2 squared, which is 4. So the corresponding point is negative 2, 4. If x is negative 3, we have negative 3 squared, which is 9. So the corresponding point is negative 3, 9. Let's graph these. So we have negative 3, comma, and I only have 7 spaces, so I have to go up a couple more. So that's 8, 9, somewhere up there. And then I have negative 2, 4. Then I have negative 1, 1. I have 0, 0, 1, 1, 2, 4, and 3, 9. So this is a parent function for a quadratic function. That's a sketch of f of x equals to x squared. Now, let's graph the inverse of f of x equals x squared by interchanging the x and y values. So what I'm going to do is I'm going to take the x's and y's and I'm going to interchange them to find the inverse of f of x. So remember, f of x is x squared, and here all I'm doing is I'm interchanging x and y to get the inverse of f of x. Okay, so the first point, negative 3, 9, this becomes 9, negative 3. The second point, negative 2, 4, this becomes 4, negative 2. The third point, negative 1, 1, this becomes 1, negative 1. 0, 0, even if I interchange them, that's still 0, 0. 1, 1, if I interchange, it's still 1, 1. If I interchange 2, 4, that's 4, 2. And 3, 9, if I interchange that, that becomes 9, 3. So let me graph both of these points. So I have 9, negative 3. So this is 6, 7, 8, 9. Negative 1, negative 2, negative 3. Then I have 4, negative 2. Then I have 1, negative 1. Then I have 0, 0. Then I have 1, 1. Then I have 4, comma 2. And I have 9, comma 3. So the inverse of f of x, it looks like this. Now here's the question, is the inverse of f of x a function? Now recall, for a graph to be the graph of a function, it has to pass the vertical line test, which means if I draw a vertical line, it has to hit the graph exactly one time. But that's not the case. This vertical line hits the graph twice, which means that, say, the input of 4 has two different outputs, negative 2 and negative 2, which we can see the same x value has two different y values. And we can say that for all of them. The same x value has two different y values. The same input has two outputs. Therefore, this is not a function. Now, the reason that the inverse is not a function is because the original function wasn't one-to-one. So in the original function, if I draw a vertical line, then it hits the graph 2 times, which means it's not a one-to-one function. So when I take this, and what I'm essentially doing is, because I'm interchanging the x's and y's, I'm flipping it over this way, then the inverse is not a function. So for a function f of x to have an inverse, then f of x has to be a one-to-one function. So a function f of x has an inverse function f inverse of x only if the original function f of x is one-to-one. Because if that doesn't happen, like in this case, then the inverse will not be a function. So the original function f of x, it has to be a one-to-one function. Okay, now here's another example. We'll take the same exact function, f of x equals to x squared, but now we are going to restrict the domain of f of x equals to x squared to greater than or equal to 0. Okay, so here's what that means. It means that in my table of values, I'm only going to include the numbers that are 0 and greater, like 0, 1, 2, and 3. So I'll have 0, 0, 1, 1, 2, 4, and 3, 9. So in this function, I'm going to eliminate the negative values. So I'm going to eliminate the left side and only focus on the right side. I'm going to restrict the domain. Okay, now let's go ahead and graph this first. So I have 0, 0, I have 1, 1, I have 2, 4, and I have 3, 9. So it's going to look like this. Now let's check, is that a one-to-one function? Well, it's going to pass the vertical line test because every vertical line hits the graph once. But it's also going to pass the horizontal line test because every horizontal line also hits the graph once. So this is a one-to-one function. Because we restricted the domain and we got rid of the left side. So now any horizontal line, if the left side doesn't exist, it's only going to hit the graph once. Therefore, this is a one-to-one function. So sometimes functions that are not one-to-one can become one-to-one with a restricted domain, like we see here. Now let's graph f inverse of x by interchanging the values of x and y. So over here, I'm going to, so this is your f of x. To find what my inverse is, I am going to interchange the values of x and y. So for 0, 0, even if I interchange them, that is still going to be 0, 0. For 1, 1, if I interchange them, that's still going to be 1, 1. For 2, 4, if I interchange them, that's going to be 4, 2. And for 3, 9, if I interchange them, that'll be 9, 3. So in blue, I'm going to graph the inverse function. So that's 0, 0. I have 1, 1. I have 4, 2. And then I have 9, 3. Now take a look. This actually is a one-to-one function because it passes both the horizontal and the vertical line test. Now for the next part, let's find the domain and range of each. The domain of f of x, the original function in red, it's all the values of x for which the graph exists. Now remember what we did. We restricted our domain so that the values of x are only greater than or equal to 0. So the graph doesn't exist for the negative values of x. The graph only exists when the values of x are 0 or greater. And the arrow indicates that the x's can keep going forever towards infinity. The range, we are looking for the smallest and largest values of y for which the graph exists. So for the range, the smallest y value for which the graph exists is 0, and it's going to go to infinity. For the next one, let's take a look at our domain. Our domain, once again, is going to be 0 to infinity because this graph, the one in blue, only exists when the values of x are 0 or greater. And same thing for the range. For the range, the values of y are 0 or greater. So our range is also going to be 0, infinity. Now, because we take the graph of all the points of f of x and interchange them so the y's become the x's and the x's become the y's, look at what we did. The range of the original function, all the y's, they became the x values of the new function. And the domain of the original function, all the x's became the y values for the inverse function, which interchanged the x and y. So essentially, the domain of a one-to-one function is the range of its inverse. Okay, so the domain here is the range of the original function because the y's became the x's. And the range of a one-to-one function is the domain of its inverse. And we'll see this more in the next few examples.